what these functions are that have the same name as our primitive types, but with an uppercase letter. They are built-in native functions that are intended to be constructor called. We'll learn about that in the next lesson. And the JavaScript compiler uses these functions to return an object that supports lots of rich features to each primitive data type, and we'll see those in upcoming lessons. But the JavaScript compiler will box and unbox your primitive types into these built-in native equivalents as needed, and we'll do so without any help from you, and we'll do it all behind the scenes. And you can explicitly create instances of these objects and then use the value of method like we saw here just a moment ago to convert them into their primitive equivalents, but it's not really necessary. So, what's this new keyword all about? And what's this uppercase letter in this function name all about? Well, I'm going to explain that in the very next lesson. We'll see you there. Thanks. So previously we saw how to create an object literal using this style of syntax, and you'll note that I've already created a file called constructors.js. Go ahead and take a moment to create that yourself if you want to follow along. I'm just going to paste in the car that the literal car that we created in a previous lesson here with the make, model, and the year property set to BMW 745 Li and 2010 respectively. Now, there's actually another technique for creating an object, and that's through the use of what are called constructor functions. So let me go ahead now, comment this out, and then let me go and create a new function, and I'm going to name it car, and it'll have some input parameters, one for each of the properties that I want to initialize upon the creation of the object that gets returned from this function. So make, model, and year. And then we're simply going to say, hey, the object that gets returned, set its make property to the make input parameter that was passed in as the first input parameter. And you're going to add a model property to that object, and you're going to set it equal to the model parameter that was passed in. And then you probably guessed what this next line of code will do. Same thing with year, right? And most importantly, whenever you're creating an object using this function, it requires the new keyword. So let my car equals new car with a capital C. Did you notice that I named my function with a capital C car? I'll explain that in just a moment. And IntelliSense tells me that it requires 3 input parameters into this function. So here we'll go BMW 745 Li 2010. All right. And so what's really going on here, and let's just go ahead console.log just to prove there's nothing up my sleeve here. My car. And here we're going to go node constructors. And there you go. We get a car object that has the properties make, model, and year populated. All right. So what's going on here is that the new keyword creates an empty object. Calling the function, in this case car, it will take that empty object as the this. Remember our discussion about how the this keyword gets bound to the context from which it's called? Well, in that case, that new object becomes the context for this function call. And so this empty object starts receiving new properties on lines 8, 9, and 10 with new values set to those new properties. What gets returned from this whole thing with the call to this function is an object with properties make, model, and year already set. All right. So it's important to remember that the functions themselves that we define here beginning of line 7 are not constructors, although if you're coming from another programming language like Java or C#, you might be inclined to think in those terms because that's how they work. But rather in JavaScript, it's the new keyword in front of any normal function, any function, that makes it a constructor call. All right, it creates a new empty object, and it will pass it as the this to that function call that you make. So the new keyword kind of elbows its way into the execution. Pardon me, excuse me, I need to get in here. And it says to the function, first, before you execute, I need to create an empty object and give that to you in the this. So it's bound, so this is bound to this new empty object. And then it says, okay, now you can continue to do whatever you were going to do. Now, the function itself could ignore that new empty object, or it could use it like we have in 8, 9, and 10 here. All right. So just to kind of prove that, let me go ahead and comment all that out. And let's create a function, my function. And I'll just do something simple like, hey, I am a simple function, right? And then we're going to go var my function equals new my function. And then we're going to go console.log type of my function, or actually let's go lowercase m for my function. I've got some things wrong here, like, there we go. That's what I want to do. And so let's, all kinds of problems with that line of code, but I caught them before I executed it, so that's good. All right, so you can see here in line number 21, we are creating a new empty object and then calling my function. My function executes, but not before a new empty object is kind of passed to it in the this. Now this is not used in the body of my function, so it's returned back to this variable of the same name but with a lowercase m. Probably should have chose a different name. If that causes any confusion, I apologize. Just remember, lowercase m my function is different than uppercase m my function in this particular case. But when we take a look at the type of my function, it is object. All right. And so at this point, you know, it's an object, so you can't really do anything interesting with it. It's no longer a function, so you can't do that. In fact, here, let me just kind of copy and paste this little note I put to myself in my notes here. You can't really do anything with this particular object. It's certainly not a function reference anymore. It used the function as a constructor, but the constructor function didn't really do anything to populate the properties of it. And, you know, this will not actually do anything. In fact, if anything, let's just see what happens if we run this. Yeah, we get an exception here that my function is not a function. So we really can't do that. All right. Hopefully that makes sense, the right reasons why. But the only thing you can do with, you know, what gets returned here, my function, is that you can attach properties and methods to that empty object, which is kind of the point of the new keyword entirely. All right. So what about this uppercase first letter convention? I said that it was a convention. What's a convention? What is this particular convention, you know, specifically? Well, you're basically saying my intent is that this function be called using the new keyword. That's what the convention is. Basically, I am a function, but I should be called, I should be used as a constructor, so you should only use a new keyword on me, and I'm expecting an empty object be passed to me so I can set some properties on it, or maybe add some methods, as the case might be. All right. So just keep in mind that in JavaScript, what makes a constructor function has nothing to do with the function declaration itself, but rather how the function is being called. It must be called using the new keyword in order to be a constructor function. So in the previous lesson, we learned about the built-in native constructor functions that return objects with properties and methods to wrap around the primitive types and give them essentially superpowers, giving them new properties and methods that will operate on the primitive value. New functionality like the to uppercase, the to lowercase, the length property, and others that we'll learn about. But that's why they're defined as uppercase S in string, uppercase N in number, uppercase B in Boolean, and so on. That's why you can explicitly create one of those built-in natives if you use the new keyword like we demonstrated in that previous video. So hopefully that all makes sense. If nothing else, I hope you're learning how JavaScript is all about functions, first of all, and secondly, how you call a function really changes the meaning of the function and what it's intended to be used for. It changes, even in some cases, the functionality that's defined inside of the function, like in the case of this, or perhaps changes the purpose of the function like we saw here with the new keyword and calling into the function. All right, so doing great. Let's continue on. See you in the next video. Thanks. JavaScript has objects, and we've seen how to create a literal object, and we've seen how we can construct an object using a constructor function and the new keyword, like in the previous video. In some of the most popular programming languages, you create an object using a pattern called a class, or a construct called a class. In other words, you create a class named car, and then you create individual instances of the car class as individual separate objects. Now, furthermore, you can create specialized versions of one class, borrowing all the properties of that parent class in the new child class. So you have an original class, and you say, I want to inherit everything that that original class does in my new class, and then you can extend it by adding properties and methods to it to make it a more specialized version of that original or parent class. So to kind of extend the analogy here, I may have a car class, but I want to create a sports car class that extends the definition of just a normal car, and it adds on things that make it sporty. Same thing with a minivan. It's just like a car. It has some of the basic principles of a car, but a minivan also has like number of passengers and cargo capacity, things that make it unique, a unique type of car. All right, and then I can create instances or objects based on that minivan, or objects based on the sports car, and those objects are both have similarities to a regular car, but they have differences as well. All right, so that's kind of the notion of classes and inheritance. And classes and inheritance are a foundational concept associated with object-oriented programming. Not sure if you've ever heard the term, but it's a pretty big deal among software developers. So you might be asking yourself, well, first of all, does JavaScript have classes? Well, yes and no. I mean, in JavaScript, you have objects, and you can create an object and dynamically add properties and methods to it whenever you want to. But objects are the focus in JavaScript. In languages like C# and Java and C++, you create a class and you add properties and methods to the class up front. And they're static in so much that they cannot be changed. So you can't be adding properties and method declarations to the object at runtime. I mean, you can, but it's not the original intent of object-oriented programming. They can't be changed over the lifetime of any objects that are instances of that class. So here in object-oriented programming, languages, base languages like C# and Java, classes are the focus. JavaScript, objects are the focus. C#, Java, C++, classes are the focus. The latest version of JavaScript does in fact have the concept of a class, but it's a weird little stopgap measure to help people that are trying to make the mental leap from an old language that they might be familiar with, like C# or Java, into the world of JavaScript, to a dynamic object-based programming model. So I talk about JavaScript classes in one of the upcoming lessons, and we'll get to that soon enough. But I guess, okay, so JavaScript kind of supports classes, kind of doesn't support classes. What about inheritance? Well, here again, JavaScript, yes, it kind of supports inheritance, but not really the kind of inheritance from traditional object-oriented programming. So in JavaScript, you have something different called a prototype chain. So let's suppose that you've defined a literal object like our typical car example that we've seen so many times. Won't even paste it to screen. You know what it looks like. It has a make, model, and year property, right? And so you define this literal object like our typical car example. You like the properties and the methods that you've already added to that object, and you would like to use that car object as the basis for a new car object. You'll probably wind up changing some parts of the object's definition, maybe some new values and a few of the properties. You might even add some new properties and methods to that new object. And I'm going to demonstrate a technique that allows you to construct a new object based on an existing object here in just a moment. But when you do that, when you create a new object based on an old object, something special happens in JavaScript. There is a permanent link that's created between those. The new object always knows who it inherited all those properties, its original set of properties from. How did it get created? It always knows kind of the link between it and the prototype that came before it. All right. In other words, the original object serves as a prototype for the new object, and the new object is essentially chained to that prototype from that point on. So in languages like C# and Java and C++, those traditional object-oriented programming languages, you create a class hierarchy where one class inherits from another class. So whenever you create an instance of the child class, there's really nothing that's linking that instance of the child class back to the parent class. So there's nothing linking that child object back to the parent class definition. So here again, the focus is not on the relationship of individual objects that happen to be linked to each other and kind of have a brotherhood, but rather more of a parent-child relationship in traditional object-oriented programming. Again, the relationship between classes is the focus of object-oriented programming, whereas in JavaScript, it's the relationship between objects and how they're chained together. It's a subtle but important distinction between JavaScript and traditional object-oriented programming languages. So some people use the term JavaScript prototypal inheritance. All right, but I've tried to stay away from the term inheritance when talking about JavaScript because it might conjure up traditional object-oriented programming concepts that would mislead you whenever you're considering how it all works in JavaScript. One of my favorite JavaScript authors, Kyle Simpson, called this style of object-based prototypal inheritance, it calls it really objects linking to other objects, or OLOO, O-L-O-O, objects linking to other objects. And I really like that description. And by the way, I'm not sure one way is necessarily better than the other. They're different. There are pros and cons depending on what you're trying to accomplish, the given problem you're trying to solve. So what I do want to do is have a better, thorough understanding of how objects linking to other objects actually works and what are some of the ramifications of that. So that's what we'll do in the rest of this video. So you can see that I have a new file called prototypes.js, and here I'm going to paste in my original car. This looks an awful lot like the car literal that we've been creating, object literal that we've been creating up to this point. Now I told you that there's a way to create a new object based on an existing object. And so let me do that. We're going to say, hey, let our new car equal capital O object dot create and then original car. All right, so at this point, if we do, for example, console.log new car.make, for example. So let's go node prototypes. Okay, so we have this new car, and what it looks like, at least at first glance, it appears as though we have a new object called new car, and the value of the original car has been copied in of the make property of the original car has been copied into the make property of the new car. But that's not exactly what's going on here, as we'll talk about here in just a moment. But at this point, I have two objects. I have the original car and I have the new car. And I could do several things at this point with new car. I could change the values of the existing properties that I have on new car. I could add new properties to new car, or new methods to the new car, or I could delete the existing properties from new car. All right. But more interestingly, I want to revisit something I said earlier about the relationship between the original car and the new car, that there's a link between the new object and its prototype, its predecessor, the original car. And so if we do something like console.log and we say object.get prototype of, and inside of that method, I'm going to say new car. So tell me who the prototype of this object new car is. And it'll say it's this object right here, where the make is BMW, the model 745 Li, and the year is 2010. All right. So it's pointing to this original car. So let's do this instead. We can actually get a reference to my prototype. Get prototype of, passing in new car. And then I can do console.log my prototype.make. And so you can see here that I'm able to get back to that, to the make property of the original car. Now, there's no way to really prove that because they both seem to have the same values right now, but we're going to push this a little bit further. What happens if I were to add a property to the prototype? In other words, what happens if on original car I were to add a doors property, like a doors count? So if you remember, all I need to do on an object to add a property is just go, hey, I just want a new property called doors. So I do dot doors. And then I'm going to create the value and say, hey, it's 4. Now, let's go console.log new car.doors. All right. And you can see that the new car gets this doors property and it seems to be copying that new property over, but that's really not true. But we definitely see that there's a link between the new object and its prototype, the original car. But how do I know if the property is defined on the new object or on the prototype? Well, here's what we can do. And so this is going to help us to kind of get to the bottom of this relationship right here. We're going to start with the original car and says, do you have your own property? Does this property belong to you? Or are you essentially borrowing it from your predecessor? So first of all, it's true that the original car has its own property called doors. Okay, so console.log new car, do you have your own property called doors? And that's false. All right. So kind of tying this all together and kind of explain what's really going on here. Well, whenever we attempt to get a property or call a method on an object, JavaScript will go through a series of lookups to find the value or the definition of the property or the method in order to call it. So after we created new car, it had none of its own properties. If we asked it for the value of one of its properties, doing something like we did here in line number 9, it would find the prototype that new car links to and see that if it has its make property. So we know that the new car does not have a property that we define on it called make. But what about its prototype? And yes, the prototype, the original car, has a make property and it's set to BMW. Okay. But once we do something like this, new car dot make equals Audi. All right, so we are changing the property, or actually we're creating a property on new car, and we're setting its value to Audi. At that point, what happens is, whenever we come down here and basically call the same, essentially same line of code now in line 11, it's saying, hey, new car, do you have a property called make? And new car says, yes, I do now. I have my own property called make, and it's set to the value Audi, all right? So no longer do you have to continue and look at my prototype to find the property and its value. You could look at me and find the property and its value, all right? So JavaScript doesn't need to look at the prototype chain if the property is created and set on the new object that is essentially created from the prototype. So if we ask for a property that's not yet been defined, so here we go, let's go here in line number 12, console.log newcar.whatever. All right, now think about this. Whatever property does not exist on new car. Whatever property does not exist on its prototype, the original car. So what happens next? Well, then JavaScript will traverse back and say, hey, original car, what are you linked to? And since we defined original car like this, we're linked back to type object. Actually, it is the built-in native object function. However, the whatever property is not defined on that either. So now what happens? Well, finally, JavaScript will do one final traversal asking the object built-in native object what its prototype is, and by default, it will return the primitive undefined. So when we get to line number 12, in fact, let's go ahead and comment out just about everything else here. I'm going to hit Control A there, and we'll get rid of all this just so we can kind of see what we're doing here. So at this point, what happens? We get undefined. Why? Because new car doesn't have a whatever property. We look back and the prototype, original car, doesn't have a whatever property. Its prototype, object, doesn't have a whatever property. And its prototype is undefined, and that gets returned. Okay. That's the end of the chain, so to speak. And that, my friends, is basically how the prototype chain works in JavaScript. You don't have to use this. You probably should know it, although you could probably go your whole career and not really have to ever deal with it. However, this is fundamentally how all your objects work and why you get the undefined type returned when you attempt to access a property value that doesn't exist. So I tried to make this as simple as possible, but this is a post-beginner topic. In fact, I was looking at some tutorials online and I saw that this was actually an advanced topic. But if you kind of understand what we're talking about here, just think about how far you've come in your JavaScript understanding to get to this point where you can kind of understand what's going on. That's impressive. So I would just recommend that you watch this again, you take a look at a few other tutorials online, and you give it some time to sink in, and you'll probably leapfrog over a bunch of people who are trying to learn JavaScript, but not really pushing themselves past the absolute basics. You're doing great. Hang in there. We're making great progress, and we're getting close to the end, relatively close. All right, so we'll see you in the next video. Thanks. In the previous lesson, I said that JavaScript doesn't have classes, at least not in the traditional object-oriented programming sense. Nor did it have inheritance in the traditional object-oriented programming sense. I explained how JavaScript is focused on objects and the linkage between objects that are based on objects. We also looked at constructor functions that allow you to construct a new object from a function call, but this really isn't a class in the traditional object-oriented sense either. But technically, JavaScript does actually now have classes, or the notion of a class, and it was introduced in the last version of JavaScript. Now, JavaScript classes give you the impression that you're working with something that resembles traditional object-oriented programming, But in reality, nothing has really changed. JavaScript remains object focused, and objects can still be prototype chained together. I don't know how to say it correctly. JavaScript classes are what is termed syntactic sugar on top of the existing JavaScript object and prototype models. That term, syntactic sugar, you'll see that frequently in software development circles. It's programmer slang. That means that they added a few keywords and structures in JavaScript, but these merely map to existing features of JavaScript. They don't really add new features per se. So the syntactic sugar might help those who are transitioning from more traditional programming languages to JavaScript, but JavaScript purists are quick to point out that this new feature, the class feature in JavaScript, may do more harm than good, because at the end of the day, you still have to make the switch from classic or traditional object-oriented programming to a more object-based prototype inheritance, if you want to use that term. And if you're working with prototypes, you have to learn the things that we talked about in the previous lesson. Okay, so in a nutshell, let's talk about what a class is and define a class. It's essentially a way to define and create objects. And so just like there are function declarations and function expressions, now there are class declarations and class expressions. So let's start off with just looking at a class declaration. And so you do something like class car, whereas an expression would be more like let car equal class and then whatever. Okay, so fairly simple and hopefully straightforward. It's basically declaration, you give it a name, and expression is, well, it's an expression. So JavaScript classes can have a constructor function that gets called automatically whenever you use the new keyword. So let's go with the declaration version of this. I'll comment this out, this expression. All right, so inside of the declaration, let's create a constructor function. You have to use the term constructor. Then you can add any input parameters that are essentially going to map to properties that you're going to add to a new instance of an object based on this class. So here again, you do something like make, model, and year. And just like in the constructor functions that we learned about a couple of videos ago, you would still use the this keyword, make equal make, this.model equals model, this.year equals year. Okay, so you can see similarities here, right? And then to create a new instance of an object based on this class, you would do let my car equals new car, passing in, you know, BMW 745 Li and the year 2010. Okay. So again, I want to make the point here that that word or that name of your constructor function in a class definition in JavaScript has to be named constructor in order for this to work. And here you're still using the new keyword. New still creates an object instance. It still passes it to the constructor function. Now, in this case, the name of the function is not car. The name is constructor, but you're passing input parameters into that constructor method. And then using this, in this context, it's the new empty object that we're attaching properties to and then initializing their value to the arguments that are passed into the constructor. All right, hopefully that all makes sense. And it's similar enough to what we've already learned that it kind of, you can see where things are mapped. Again, syntactic sugar on top of what already exists. All right, so you can also create methods on the class. In fact, let me do it outside of the constructor method. So here I want to create a print method, and you know, I can do something like console.log, and then I'm going to go ahead and use our special string syntax, interpolation syntax. Let's make some space for myself here, and I'll say this.make, this.model, and I'll format it a little bit with some parentheses, but inside we'll go this dot here. All right, so here again, now that I have an instance of my car class called my car, I can call print like so. And so let's go node classes, and you can see I get the nicely formatted version of the information in my car class calling the print method. All right. Now, beyond these basics, you can actually approximate inheritance, at least inheritance in the classic object-oriented programming sense. So in our case, let's kind of go down here to the very bottom, and I want to create class sports car, and I have to use the keyword extends car. All right. So right off the bat, when I do that and I create a new instance of sports car, let's do that. So let my sports car equals new sports car. Now I don't have a constructor function defined, but when I use the open parenthesis, notice that IntelliSense still sees that I have make, model, and year. Why is that? Because by extending sports car from car, I still get the constructor method defined on car, and I can still set the make, model, and the year. So here, let's go Dodge Viper. And I don't even know if there's a 2011 version of it, but I don't know if they stopped making it or if they're still making it. I'm not even really sure, but it doesn't matter. All right. So at this point, and we can even call my sports car dot print. All right. And now we get that printout here like so. So we're extending, we're borrowing the entire definition of our class, and we are getting the constructor method defined in car. We're getting the print method defined in car, but I can extend and push beyond the boundaries of the car's definition by adding properties and methods. So for example, here, let's just add a quick method. And I'm going to call it, since it's a sports car, we're going to create a method called rev engine, which will be a unique printout of information. So console.log, and we'll do something .vroom goes this dot model. Okay. So now I can call my sports car dot rev engine, and I get vroom goes the Viper. I guess I should have added a space right there. All right, now what if I were to do this? I still have my car. Can I go my car rev engine? Let's see. Nope, can't. Why? Because it says rev engine is not a function. Well, it is a function. It's just not defined on the car class. It's defined on the car class's inherited child called sports car. All right, so you can't access rev engine from the car class. And you know what? Honestly, there's more to it than that. There's some advanced scenarios, but that should be enough to show you what the class keyword and the extends keyword can do and how it operates. And you can see the rough equivalence between what we did here and what we've done previously. And hopefully you can kind of see that there is a mapping, and that ultimately what's going on behind the scenes, though, is that we're creating a sports car object, and its prototype is car, and we're adding on a rev engine method. But when we look up the constructor function, when we look up the print method, it's still using prototypes behind the prototype chain behind the scene to manage all that. It's just JavaScript is kind of covering that up just a little bit with some different syntax. Okay? So my personal opinion is that if you're coming from a traditional object-oriented programming environment and you need to become productive very quickly because you have a looming deadline or whatever the case might be, you might be better off trying something like Typescript, which was created by Microsoft. It gives you the feel of C# and Java, more so than JavaScript will. And it gives you more of that traditional object-oriented programming look and feel. And ultimately, it will transpile down to pure JavaScript. Kind of out of the context of this conversation, just what you should do is go to typescriptlang.org and you can study up on it a little bit, but it's essentially a super type of JavaScript, meaning anything you do in JavaScript will work in TypeScript, but TypeScript gives you some extra features that will make it feel more like Java or C# if that's something you need. But most importantly, if some of this doesn't make sense, the things that we've talked about here, don't beat yourself up about it. Again, this is a feature that was added for a specific demographic, people coming from other programming languages. It may not have been intended for somebody who is just starting to learn JavaScript. So don't feel like the pressure now to go out and learn traditional object-oriented programming before you can understand how to use class. You don't even need to understand this. It's just, again, something for a stopgap measure for people coming from another programming language. So it might not be immediately obvious to you in what situation you might find yourself using this and why you would prefer this over what we looked at in the previous lessons. But at this point, just focus on the language, the fact that these things exist, the fact that they were added for a reason, and the reason is to help somebody else, maybe not you specifically, somebody coming from a different background, to make that transition to JavaScript. And you know, ultimately, I think with a lot of the things that we're talking about here, their usefulness will reveal themselves to you later whenever you start programming and creating real applications with this language. All right, so you're doing great. Just hang in there. We're making great progress. You know, the fact of the matter is that learning is iterative, and if this is your first attempt at learning any programming language or your first attempt at learning JavaScript specifically, no doubt you're going to need to come back to some of the ideas that we talk about, you know, in the coming days, weeks, or months. And you'll continue to come back to some of these ideas over and over. I mean, I keep studying and kind of pushing in new directions, coming back to studying the basics and then pushing a different direction. And you have to do that in order for these ideas to fully sink in over time. I mean, I've been working with JavaScript almost my entire career and I'm still learning things. So it's just the nature of learning this sort of stuff. There's so many details and there's only so much time in the day. So don't beat yourself up. You're doing great and you're taking great strides towards understanding JavaScript. So hang in there. We're just kind of entering the home stretch now. You've come so far, just a little bit more, and then you can honestly say that you've got a firm foundation of JavaScript to build on. Okay, a little encouragement to get you over the hump here. All right, we'll see you in the next video. Thanks. In the most recent version of JavaScript, you can define a function using a shorthand syntax called arrow functions. And arrow functions, since they are just a shorthand syntax for creating a real function, and functions are used everywhere in JavaScript, as you know by now, you might not be surprised to hear that there are many different ways that arrow functions are used in JavaScript, and there are many different syntax variations to boot. So what I want to do is start simple, and I want to look at a few practical applications of arrow functions, but we'll start using them as frequently as possible from this point on, and you'll begin to see them pop up just about everywhere. All right, so you can see that I have a file called arrowfunctions.js that I've already created, and I want to create my very first super simple arrow function. So here we go. I'm going to create a function called hi. I'm going to set it equal to a set of empty parentheses, what's called the fat arrow operator. So equal sign and a greater than symbol after it to kind of resemble a fat arrow, I guess, as opposed to a thin arrow, which has absolutely no meaning in JavaScript. This fat arrow then will point to a body defined by an opening and closing curly brace. And then we'll do console.log howdy. Okay, so far so good, right? One line of code, an entire function declaration, and we can just call hi. So here we go. Let's go node arrow functions, and we get a simple word howdy printed out. Okay, that's easy enough. So let's comment that out and move on to a slightly more interesting example. we can actually go let hi, and inside of the opening and closing parentheses, we can accept an input parameter. So what these really are, instead of using, the keyword function, we just get rid of the keyword function. But this remains, and it allows us to define an input parameter, name. Inside of, or after the fat arrow, and inside of the body, I can go console.log. We use our special backtick character, and we'll go howdy. And then $, open closing curly brace, name. Add a few semicolons to the ends of some things here. Really probably don't need this one per se. Now let's call hi, Bob. Howdy, Bob. Okay, so you can see that all we're really doing here is just creating, again, a shortened version of a function. And we don't need the keyword function. We just go ahead and start with the opening, closing parentheses to define the area where we can add input parameters. The fat arrow points to the body of this arrow function. And inside of there, we can just do whatever we want to do, just like we can in any normal function, even reference input parameters like we've done here. All right. Now, up to this point, we've just been kind of creating what I call void functions. They don't return anything. But what if we need to use the return keyword? Let's create a different version of this. So we're going to create add equals, here we go. We're going to allow this to take two input parameters, A and B, and we'll just do something super simple. We'll here once again, but we will use the return keyword, A plus B. And now we can do console.log add 7, 3, and we get 10 printed to screen. Okay, can you see this same basic structure? Here we're accepting two input parameters separated by a comma. Here we're still referencing those in that body that we've defined using open and closing curly braces. Use the return keyword. It'll get returned to our method as a return value of our method call. And here we're just passing in numbers, getting that value back and printing it to screen. Okay, so far pretty easy stuff, right? Now, you might be wondering, how could I ever use this sort of thing? What is its pertinence? And so I think that one of the ways that I see them being used the most is whenever you need to run a function over each element of an array. And so let's use our let names equal, and you'll recognize these names once again. Okay. This time, we're going to call the map method. Now, this happens to be a method defined on the array built-in native object that we learned about, but we'll talk about more of these helper methods built into the array built-in native object in an upcoming lesson. But the map is a pretty cool one, because what it allows us to do is to basically iterate through each element of an array, and when it iterates through, it will actually allow us to call a function. And this is a perfect spot for creating, right inside of here, one of our arrow functions. So in this case, we'll say you're going to iterate through each element of names. Whoops, I need to use the right word here. Names, right? And so here we're going to create an arrow function that accepts a name. And what we'll do is, kind of to marry these two ideas together, console.log, and then howdy name. All right. And you can see, basically in one line of code, I was able to map each element of the array to our arrow function. It passes in the name to the arrow function. In the body of the arrow function, now we can simply operate on it just like we were doing previously. But as a result now, for every single element of our array, we're getting a console.log with our little message. Okay, pretty cool, pretty cool. Let's take this one step further as we continue to build on this idea. Let me grab this line again so I don't have to retype that. And then I'm going to say let I equal 0. And actually, let me just grab this line too, because I want to do something a little bit more interesting. Because I want to show that you can actually do a little bit more in a single line. Like, for example, here I might increment the value of I and then use I here in the body. But now I'm essentially doing, you know, two commands or two statements inside of the body. And I'm not saying you'll do this very often, but it's certainly possible. All right. So now let's do save that. Get back to that. So now David 1, howdy Eddie 2, howdy Alex 3, howdy Michael 4. All right. All right. Let's continue to build on this. And now let's use the return keyword, kind of in the same, doing the same sort of thing here. So we'll start off with names. In fact, let's go var transformed equals names.map. And then I'm going to borrow some of these pieces here again. I'm just going to borrow that. Except I'm not going to call console.log. I'm just going to return that string. Let's see if we can get this all kind of lined up here. Okay. So I'm going to take every name in names, and I'm going to return howdy plus the name. And now I'll do console.log. The entire array that is going to be returned from this and saved into transformed. So here we go. Whoops, I got to spell log right. All right, and so you can see that what gets returned here, because we're returning multiple values, they get added to essentially an array. And now you can see on each element of the array is the literal string that we construct inside of this map function using an arrow function to do the construction. And those individual names are now transformed and saved into a new array. Instead of just David, Eddie, Alex, now it's howdy David, exclamation mark, howdy Eddie, exclamation mark, and so on. All right. So arrow functions are simple to create, and they're just a shorthand version of function expressions. They really are useful whenever you're working with functions on arrays, like this map method that allows us to map each element of an array to one of our arrow functions, and then basically execute that function against each element of the array. And so we'll see some other examples of this in some upcoming lessons. All right, pretty cool stuff. All right, we'll continue on in the next video. We'll see you there. Thanks. Designing a course can be challenging sometimes because when you finish a topic, there's a number of directions you can go after that topic. But if you have an overarching idea that you want to get to eventually, you're going to have to kind of leave some important thoughts on the side and come back to them later. And that's really what's going to happen in the next 4 or 5 lessons or so. These are topics that could have easily been covered much earlier in the course, but because I was trying to get somewhere, I left those details off till now. So hopefully you don't mind that we're going to circle back and fill in some of the, or backfill some of the topics that we just didn't cover in a lot of depth. And the first that I want to talk about are these terms truthy and falsy, which seem to be specific to JavaScript. I haven't seen them used in other programming languages. Maybe I just haven't looked at the right programming language. But basically, it has to do with evaluations. So when you evaluate an expression, like for example in an if statement or in a switch, and you perform an evaluation of expressions, sometimes they're going to return absolute true or false. 1 is greater than 2. That is false, patently false. And I would expect that I would get from that expression the false value. But then there are other things that are not quite as obvious. And there are rules in JavaScript that dictate whether an expression is truthy. It's in and of itself, it doesn't look like it would be true, but because of the rules of JavaScript, it is true. And things that are falsy, it doesn't look like it would be false, but based on the rules of JavaScript, we're going to call it false. All right. And so if you just don't know what those are, you're going to maybe perform or evaluate an expression. You're going to get a true or a false, and you're going to be like, what in the world's going on there? Why is that true? Why is that false? So I want to cover these cases, and I hope you don't mind that I'm just going to copy and paste these right in because it's a pretty big chunk of code, and we'll just look at these things. But in the top, these are things that are falsy. Well, right off the bat, in line number 1, if you're going to evaluate an expression, if false, that's always going to be false. That's not really falsy. It's just false. All right. But then there are things like null, if null. Well, in and of itself, null, if we're looking at this completely subjectively, null is not true or false. It doesn't really have a connotation of being true or false. It's just null. We'll talk about null later. However, it's considered by JavaScript to be a falsy value. Same with undefined. Undefined is not good or bad. It's not true or false. But JavaScript says that if something pops up and after evaluating an expression, it comes to undefined, that's going to be a false value. The same with the number 0. If an expression is evaluated and what's output is the number 0, that is a falsy value. It will return false in that expression. Same thing with not a number. Same thing with an empty string, whether you use in lines 6 or 7 single quotes or double quotes to define your string. Now, everything else is pretty much truthy. In fact, I don't even know if there's the notion of truthy in JavaScript. It's just everything that's not in falsy is essentially truthy. But I gave you some examples here. Obviously, just like if false is falsy, if true is going to be truthy. It's just true. But things like an empty object, if you evaluate an expression and it returns an empty object, for the purpose of truthy and falsy, it's truthy. Same thing with an empty array. Same thing with a string that's not empty. So we saw empty strings are falsy, but a string, if you have something in it, it's truthy. Okay, a new instance of an object is truthy. Even though there's nothing associated with, there's no properties or methods, doesn't matter, truthy. Same thing with any non-zero value, whether it be an integer or a float, which means values after the decimal point, those are all truthy, as is a constant in JavaScript called infinity, whether positive or negative infinity, all truthy values. So here again, if you ever come across something in an evaluation, it returns an odd value that doesn't strictly return true or false. It returns null or undefined or not a number or 0 or an empty string, falsy. It's going to the evaluation of that expression will be false. But everything else is pretty much going to return true. Okay, that's all I needed to say in this video. Hopefully that makes sense. All right, we'll see you in the next video. Thanks. Continuing the sentiment from the previous lesson where we're kind of doing a roundup of topics that by all rights could have been discussed earlier in this course, but we're going to introduce them now. I want to talk about the last of the data types that we'll encounter. the data type null. So it basically, null represents a variable that points to nothing, but an object reference was expected in that case. So just as a quick reminder, you can create a variable and not set any value to it, not initialize the value, not set the value.